So now we've got a clean data set, we can look at how to do some basic selecting of columns and rows and basic filtering of the data. All basic skills that you'll need. So let's first of all look at how to select a specific column, a specific variable, also known as a series in pandas. For that, we put the name of the variable containing our data frame, df_2 in this case, and then in square brackets, the name of the column, and that has name, since it's a string, a text, it has to be in inverted commas, single or double. In this case, I've used double. And so if I enter that, you'll see it does return that column, gender, together with the index numbers here alongside. Now I could have stored that in a variable of its own, so that later on I could refer to that column without having to keep typing this whole thing. What about selecting several columns? Again, same thing, df_2, the data frame. Notice the double brackets here because the outside brackets is the syntax for putting in a variable name. But then what we then have to do to choose more than one variable name is to put those in square brackets themselves, because what we're actually putting inside here is what's called a list in Python, and a list is contained within its square brackets itself. So within the outer brackets, we then put a list inside that of two or more variable names, since it's a list, they are in square brackets themselves. And notice they're separated by a comma, and of course you need quotes around the text. So that, as you can see, should return both gender and site, which it does. So those, and it returns a data frame itself, but with just the first two columns rather than all three. Now again, you could have stored that. If you're going to operate on this particular subset here, you might want to store that in a separate variable, so you can use that rather than having to type this thing in all the time. Now, what about selecting rows? Well, first, how do we select a single row? For that, we use the LOC function. So it's df_2.loc, and then again, notice the square brackets here, double square brackets. And this is going to select row 25, which is this one. Well, of course, it will select from the whole data set. So in fact, it will be that one there. So let's return that. And there we go. Now, you might want to select a range of rows rather than a single one. For that, we use what's called the splice operator in Python, which is a colon. So again, using the .loc function, again, notice we don't actually need double brackets here. We simply put in single brackets 5:15. That will return rows 5 to 15 from your data set, like that. Notice that there's no row 7 or 12, because there, of course, were rows that were removed because they contained missing values. Now, you might not want to return all the columns when you select a range of rows. You might just want one of them or two of them. How would we select rows, a range of rows, and only return the gender variables, the gender observations? Well, we do this. It's fairly obvious. Again, LOC, and then in square brackets, of course, and then firstly the range of rows, 3 to 7, 3:7, comma, and then the name of the column we want. Notice that does have to be in square brackets, and of course the name in quotes. So that should return rows 3 to 7, but just the gender variable, which it does. Notice, in fact, we don't get row 7 because, of course, row 7 doesn't exist. that was one of the rows we eliminated because it had a missing value. So we're actually getting 3, 4, 5, and 6 here. Now, what about a range of rows, but returning 2 columns rather than 1? I think that's fairly clear what we're going to do here. Same syntax, LOC 8 to 20, 8 comma, and then of course since we're selecting more than 1 column, we need those things, 2 names in brackets themselves, because it's a list, and that should return 8 to 20 with variable site in usage. Again, there's no 12 because that was one that we eliminated because it had a missing value, and 16, as you can see, is also missing because we eliminated that one. So that's how to select columns, a single column, more than 1 column, a single row or a range of rows, and a range of rows with only specific columns. So it's easy to subset your data in this way. One other way you might want to subset your data, of course, is by filtering according to some condition. For example, you might only want to look at those respondents, those cases where the respondent was male. So what we need to do is to filter on the gender column. So we just go back to the full data set here quickly. Here's our full data set, df_2. We want to filter on the gender column and only choose those rows, those cases where the gender is equal to M. Well, we already saw how to do that up above, if you remember, in the previous video when we use the query function, which is the easiest way to do it. There are other ways, I think this is the easiest. So we use the query function, and then in round brackets, we put the condition in inverted commas. So here I'm looking for those rows where gender is equal to, remember the double equal sign here because it's a comparison to M. Now notice, since M itself is a string, I need to put that in quotes. And in fact, what you have to do is if you use double quotes around the expression, then anything within that has to be in single quotes. I think if you put double quotes around the M, you'll get an error. So just be careful on this. If you've used double quotes around the expression, use single quotes within the expression for any string. So this should return only those rows where gender is equal to M, to male, which it does. So that's how to filter on gender. You can also, of course, filter on more than 1 column by using Boolean expressions, in other words, and or, and not. So for example here, I want to select columns, rows rather, where gender is M, and, so you use the Boolean and operator here is an ampersand there, and site is equal to Twitter. So that should filter even further on this data set here by only choosing these rows where the site is also Twitter. You can also use OR, which is a vertical line, which you'll find in your keyboards, or you can use not, which is an exclamation mark. I won't look at that here. It's fairly easy to do. So that, as you can see, has returned only those rows where gender is M and site is Twitter. So as you can see, it's easy to filter your data set to concentrate only on certain cases. You can filter on a single row or on more than one, on 2 or more rows by using what we call Boolean expressions, using the and or and not operators. Here, of course, I could, for example, have looked at where the gender was male or site was Twitter by using the OR operator. As I say, it's a single vertical line, which on my Mac keyboard here is above the backslash is Shift / key. On Windows keyboards it may be different. Now finally, let's look at how to firstly do a little frequency count, a frequency distribution of one of the variables, one of the categorical variables, gender in this case, and how we can then graph that frequency distribution. I'll be doing a whole video tutorial on the graphing features, but here I'll show an example. Now, how do you do a simple frequency count on a particular categorical variable such as gender? Very easy. Just use this value underscore counts function. So I want to do a frequency distribution, frequency count on the gender variable. And here I'm going to do it on the original data set here. No, actually, let's do it on the cleaned up one, the one with no missing values, which of course is df underscore 2. So I'll just change that to df underscore 2. I then need to choose that particular column, which as we've seen we do it with this syntax here, square brackets and then gender within that in quotes, and then a dot to use this particular function value underscore counts. It's a function, so I need these brackets at the end. I'm not going to include any additional options, so nothing in the brackets. So that should do a count, a frequency count of the gender variable, and here we go. You remember that in our cleaned up data set there were 31 values, and in fact there are 19 male and 12 female respondents in that cleaned up data set. Now if I wanted to plot this frequency in a bar chart, which is the obvious one to use for a frequency thing, I can do that here. So again, let me just change this to df underscore 2 so that I use the cleaned up data rather than the full data set, which of course had some missing values. So again, what I need to do is to select that variable and then apply the value counts function to return the frequency count. But what I've also done here is I have included an additional option here in the value counts function, normalize equals true. What that does is it, rather than returning the actual number, the actual count, the actual number of values in this in the gender variable, the number of men, the number of women, male and females, it actually converts those to proportions. So it tells me what proportion of my data set were men, were male, and what proportion were female. I then want to plot that data. So notice how you just continue on with the dot notation. Here I'll be looking at this in more detail in later videos. So having selected this particular column and then returned the frequency count as proportions, I then want to plot those as a bar chart. So as you can see, you just keep on adding additional functions using the dot notation to get what you want. So this is going to and to get a bar chart, it's just plot.bar. That's a function, hence the brackets here, and you can in fact include some options in there if you wish. What I then do is, using the matplotlib package, and notice if you remember how we imported that as PLT, I can then format my bar chart. If I didn't do this additional formatting here, you'd still get a decent chart, but you can format it to look better. I won't explain here exactly what these do because I'll look at these in the video on plotting graphs, but I'm just using a number of commands in matplotlib, which I'm used to. And remember, I don't need to keep typing matplotlib.pyplot. I use that alias plt xticks function here a couple of times to rotate the labels on the horizontal axis and center them, and to put better labels rather than just M and F. And then this one's fairly obvious, to put a title to the graph, and then finally to show the graph. So if I run all of those, I get my nice bar chart here with nice labels here, because I use these xtick functions here with gender. I could in fact have added a label here on the y-axis as well. Here's my title, and here notice are the proportions rather than the actual count, actual number. So that shows you how you can get a nice little bar chart very easily. And I say I'll be looking in detail how to use matplotlib to plot various charts in a separate video. Okay, so that concludes looking at some of these basic skills that you need to begin data analysis: how to import data, how to clean it up, how to select individual variables, individual columns, or individual rows, or a subset of the, and how to filter to get a subset of your actual data. And finally, just a little example of how to plot a chart.